Yay, calculus! Alright, moving on to number 50 here. Very similar to last one. What is nice though is that x and cosine are lined up and y is defined as a function of sine of t. And so this looks like an ellipse. It's going to be a little bit longer on the y and short on the x. And we're over here at 3 pi over 4. So this time we actually will have a positive b. Let's go ahead and differentiate with respect to t. dx dt is equal to negative 3 sine of t, and dy dt equals 4 cosine of t. We'll go ahead and evaluate this now because we'll need it over here when we do the y equals mx plus b part. So dx dt evaluated at t equals 3 pi over 4. It'll be negative 3. Sine of 3 pi over 4 is radical 2 over 2 equals negative 3 halves radical 2. And dy dt evaluated at t equals 3 pi over 4. Give me 4 times the cosine of 3 pi over 4, which is going to be negative radical 2 over 2. Which these two cancel. We'll wind up with negative 2 radical 2. So just got that out of the way because we'll need it over here at y equals mx plus b. So we already have our, well, we won't go out of sequence. So dy dx equal to dy dt over dx dt. And we're going to be evaluating these at t equals 3 pi over 4 anyway. So I suppose we can just go ahead and shift this evaluation. Let's go ahead and evaluate. If you're lost a little bit, go back to the previous video. See how we did it. So if we evaluate this as 3 pi over 4, all this evaluated at t equals 3 pi over 4 is going to be dy dt evaluated at 3 pi over 4, which is negative 2 radical 2, over dx dt evaluated at t equals 3 pi over 4, which is negative 3 2 radical 2, which we can do some canceling here. That'll go, that'll go. Negatives go to positive. 2 divided by 3 halves. Same as 2 times 2 thirds is 4 thirds. So that's our slope. Y is equal to dy dx. So y over here at sine of 3 pi over 4 is going to be radical 2 over 2 times 4. And those go out. So that's 2 radical 2 equals m 4 thirds x at 3 pi over 4. Cosine of 3 pi over 4 is going to be negative radical 2 over 2. And so it'll be negative 3 halves radical 2 and plus our b. Solving up b, see, 2 radical 2 equals, we can cancel these 3's, we can cancel this 2 and this 4, make it 2. So when we do that, this is all gone, that's gone, so it's negative 2 radical 2 plus b. Add 2 radical 2 on both sides, we get 4 radical 2 equal to b. And our tangent line is y equals 4 thirds was our slope, x plus 4 radical 2. All right. 51, same deal. X being defined as secant of t. X is 3 secant of t. Y is 5 tangent of t. 5 tangent of t, and evaluating at t equals pi over 6. Put it in the calculator to see what it looks like. I don't care too much right now. We're just going to do our job and be done with it. But it's always good to have a visual. By all means, as you're doing these, go ahead and put this in parametrically into your TI-84s or 83s. It'll either one will work. And then see where this is. Use your trace. And then picture the tangent line to validate your findings at the end. So dx dt is equal to the derivative of secant is secant tangent. And the derivative of y with respect to t, derivative of tangent secant squared. And let's evaluate these at pi over 6. So 3 times the secant of pi over 6 tangent pi over 6. And that's going to be 3 times 1 over the cosine pi over 6 times the tangent of pi over 6. Tangent of pi over 6 is our short ones. Pi over 6 is over here. Radical 3 over 3. These 3's can cancel out. Cosine of pi over 6 is radical 3 over 2. 1 over radical 3 over 2 will be 2 over radical 3 times radical 3 still from up there. So let's go out. So dx dt at pi over 6 is 2. Try dy dt. So dy dt evaluated at t equals pi over 6 will do 5 times 1 over the cosine squared, right? Because secant is 1 over cosine, pi over 6. And that's going to be 5 times cosine of pi over 6 is radical 3 over 2. Squared, which is 5 times 1 over 3 over 4. 5 times 4 over 3, which is 20/3. That's our dy dt, that's our dx dt. We're comfortable with the fact that dy dx evaluated at equals pi over 6 is the same as dy dt evaluated equals pi over 6 over dx dt evaluated at t equals pi over 6, which in our case is dy dt 20/3 divided by dx dt, which is 2. Sorry if that looked a little sloppy. 20/3 divided by 2 is going to be 10/3. That's our slope. Slope is first derivative. So we go ahead and do y equals mx plus b. I already got our m down, 10/3. B is what we'll solve for. Just need our y and our x. We'll evaluate that at t equals pi over 6. Our y, tangent of pi over 6 is radical 3 over 3. So that's going to be 5 radical 3 over 3. And x, secant is 1 over cosine. Cosine of pi over 6 is radical 3 over 2. So that'll be 3 radical 3 over 2. Alright. So we have 5 radical 3 over 3 equals, and let's see, this 3 and this 3 can cancel. This 1 go to that. 2 and then 10 make 5. That's another 5 radical 3. Over, oh no, there is no 3 done there. Just 5 radical 3 plus b. So we'll wind up with 5 radical 3 over 3 minus 5 radical 3 equals b. And this 5/3 minus 5 times radical 3. Let's run this up over here. So we have 5/3 minus 5 is 5/3 minus 15/3, which equals negative 10/3. So that's our that's the 5/3 minus 5. So our b is equal to negative 10/3 radical 3. So our solution, the equation of our tangent line, is y equals where our slope go. Our slope is 10/3 x minus 10 radical 3 over 3. And these two could cancel. You could have 10 over radical 3. But I don't see any harm leaving the denominator rationalized.